There are hundreds of local AI models you could download. New ones appear every week, and the leaderboards that rank them will mostly just confuse you. People spend days chasing the top model on some chart, download it, and find it is wrong for what they actually need. I pick models for real production tasks, the stuff that runs in my pipeline every day, and I can tell you that choosing well is not endless trial and error. It is a short, repeatable method. Let me hand you that method, step by step, so you can stop guessing and start picking on purpose. Let me start by killing the leaderboard trap because it derails everyone. Those rankings measure how models do on standardized tests, broad academic style benchmarks. That tells you something about general capability, but it tells you almost nothing about how a model will do on your specific task with your specific style of input. A model that tops a reasoning chart might be mediocre at the plain summarizing you actually need, and a humbler model might be perfect for it. So the first rule is this: the leaderboard is a rough starting filter at best, never the final answer. The only ranking that matters is how the model does on your real work, and we will get to how to measure that. Step 1 of the method is to define the job concretely before you look at any model. Now, I need a good model, but I need to summarize articles into 3 bullet points, or I need to classify messages into categories, or I need to draft replies in a certain tone. The more specific you are, the easier every later choice gets. And crucially, name how hard the task is. Is it the kind of ordinary work a small model handles well? Or is it genuinely hard reasoning that needs something bigger? That honest difficulty read determines what size you should even be looking at, and it saves you from both overspending on a giant model and underspending on one that is too weak. Stevens damit Harris, Unity Pfeifens Tinitich instantly. You know your card's memory. You know the rough VRAM math, about half a gigabyte per billion parameters at 4-bit compression, plus a buffer for context, so you can immediately rule out everything too big to run well on your machine. There is no point falling in love with a model that will spill onto your CPU and crawl. This step turns hundreds of options into a manageable shortlist of models that actually fit and run fast on what you have. Constraints are your friend here. They do most of the narrowing for you before you have to think hard about quality. Step 3 is choosing between a general model and a specialized one. And this is where real judgment comes in. Some models are generalists, decent at a bit of everything. Others are specialized, tuned hard for one kind of work, like coding or a specific language or following instructions very precisely. If your task is narrow and well-defined, a specialized model that matches it will often beat a larger generalist because it was shaped for exactly that job. If your task is varied, a good generalist is the safer pick. So match the model specialty to your task's shape. A coding-tuned model for coding, an instruction-tuned model for following structured directions, a general one for mixed everyday work. Step 4 is the size and speed trade, made concrete. Within your hardware ceiling, a bigger model is generally more capable but slower, and a smaller one is faster but weaker on hard cases. So pick based on your task's difficulty and your speed needs. If you are running something hundreds of times a day and need it fast, lean smaller, as small as you can go, while still getting good results. If you are running something occasionally, where quality matters most and speed is irrelevant, push to the biggest model that fits. And remember the rule from the quantization video: a bigger model at heavier compression often beats a smaller model at light compression for the same memory. That is a real lever in this trade. Step 5, and this is the one almost nobody actually does, is to build a tiny test of your own. Take 5 or 10 real examples of your actual task, not benchmark questions, your real inputs. Write down what a good answer looks like for each. This little set is your personal benchmark, and it is worth more than every leaderboard combined because it measures the exact thing you care about. It takes maybe 15 minutes to put together, and it transforms model selection from a vibe into a measurement. Once you have it, you can run any candidate model through it and see, in concrete terms, which one does your job best. Naitanius Ivan Sik is the runoff. Take your shortlist of 2 or 3 models that fit your hardware and match your task type, and run all of them through your little test set. Compare the answers directly, side by side, against what you said a good answer looks like. You will usually see a clear winner fast, and often it is not the one the leaderboard would have picked. Sometimes the smaller, faster model is plenty good and you take it for the speed. Sometimes one model just gets your task in a way the others do not. This head-to-head on your own examples is the heart of the whole method. Everything before it was just narrowing down to a fair contest. Let me name a few honest things that trip people up during this. First, do not judge a model on one example. Run your whole little set because models are inconsistent and one lucky or unlucky answer misleads you. Second, pay attention to consistency, not just peak quality. A model that is reliably good is better for production than one that is occasionally brilliant and occasionally broken. Third, factor in the speed you measured, not just the quality, because a slightly better answer that takes 5 times as long is often the wrong trade for high-volume work. And fourth, write down which model won and why, because in a month you will not remember, and the new models that appeared will tempt you to start over from scratch. Let me talk about when to revisit your choice, because models keep improving and you do not want to chase every release. Once you have picked a model that passes your test set and runs fast enough, stop, use it. Resist the urge to swap to every shiny new model that gets attention. The right time to revisit is when your needs change, when a task gets harder, or when enough time has passed that a meaningfully better model in your size class has clearly emerged. Then you pull out your same little test set, run the new candidate through it, and only switch if it actually beats your current one on your work. Your test set makes that decision fast and objective every time. Let me dig into the instruction following trait, because it matters more than raw intelligence for a lot of practical work. Some models are tuned to follow directions precisely, to stick to the format you asked for and do exactly what you said. Others are smarter in some abstract sense, but loose about following instructions, drifting from your format, or adding things you did not ask for. For automated tasks, where you need the output in a specific shape every single time so your code can use it, a reliably obedient model beats a smarter but flaky one every time, so when you test, do not just judge whether the answer is good. Judge whether the model did exactly what you asked, in the format you asked, consistently. That obedience is often the deciding factor for production use, and the leaderboards completely miss it. Let me talk about the base model versus the tuned variants, because this confuses people downloading models. A single model often comes in a few flavors. There is a base version, which is raw and not great at following chat-style instructions. And there are tuned versions, shaped to be helpful assistants or to follow instructions. For almost everything a normal person wants, you want a tuned instruction-following version, not the raw base. Grabbing the base model by mistake and concluding the model is bad is a common beginner error. So when you see several variants of the same model, look for the one labeled as instruction-tuned or chat-tuned. That is the one built to actually respond helpfully to your requests. Let me give you a sense of how to read a model's description. Because the names and labels carry real information, once you know the code, the number tells you the parameter count, which drives both capability and how much memory it needs. Words like instruct or chat tell you it is tuned to follow directions. A mention of a specialty, like code or a particular language, tells you what it was shaped for, and the compression label tells you the size and quality trait. So a model name is not random noise. It is a compact spec sheet. Learning to read those few signals lets you filter a long list of candidates down to the few worth actually testing, without downloading any of them. That filtering skill saves enormous time. Let me address the temptation to always grab the newest model, because the field moves fast and it is easy to feel behind. A new model gets attention, and you feel like your current pick is now outdated. But newer does not automatically mean better for your specific task. A new model might top a benchmark, while being worse at your particular narrow job. This is exactly why your own test set is so valuable. It lets you check whether a new model is actually better for you, objectively, in a few minutes, instead of swapping on hype and hoping. So stay aware of new releases, but do not chase them. Run the ones that look genuinely promising through your test, and switch only when one clearly wins on your work. Let me name a practical reality about disk and clutter, because it sneaks up on you. Each model you download is several gigabytes, and during this selection process, you will pull several to compare them, That adds up fast, and before long you have a folder of half-tested models eating your storage. So part of the method is housekeeping. Once you have picked your winner, delete the candidates you rejected, keep the one or two you actually use. There is no point hoarding models you tested once and discarded, because if you ever need them again, downloading is quick. A tidy model folder is part of a setup that stays manageable rather than slowly filling your disk with experiments you forgot about. Let me share how I handle the case where no single model is best at everything, because that is common. You might find one model is great at your summarizing task, but weak at your classification task, while another is the reverse. The answer is not to force one model to do both. It is to use different models for different jobs. I run several models in my setup, each picked for the specific tasks it is best at, and my code routes each task to the right one. That sounds complex, but it is not, because once a model is installed, switching to it for a particular job is trivial. The leaderboard mindset pushes you toward one champion model. The practical mindset accepts that the best setup is often a small stable of specialists. So here is the whole method in order. Define the job concretely and rate its difficulty. Find your hardware ceiling and rule out what does not fit. Choose general or specialized to match your task's shape. Pick a size that balances capability against the speed you need. Build a tiny test set from your real inputs. Run your shortlist through it head-to-head and pick the winner on your work, weighing quality, consistency, and speed. Then stop and use it until your needs genuinely change. That is repeatable, it takes under an hour, and it beats weeks of leaderboard chasing every time. Let me give you a concrete walkthrough of the method on a real example, because seeing it run end-to-end makes it stick. Say my job is to draft short, polite replies to routine messages, running automatically dozens of times a day. That is an ordinary task, not hard reasoning, so I am looking small. My card holds 8 gigabytes, so I rule out anything that will not fit comfortably, which leaves the 7 and 8 billion class. The task needs reliable instruction following and a consistent tone, so I favor instruction-tuned models over raw generalists. That gives me a short list of maybe 3. I grab 10 real messages, write what a good reply looks like for each, and run all 3 through them. One model produces consistently on tone and format, so it wins, even though it was not the top of any chart. I delete the other 2 and ship it. That whole process took under an hour. Let me flag the most common way people sabotage this method, which is skipping the test set because it feels like extra work. They do everything else, narrow by hardware, pick a type, then choose the final model on reputation or a chart instead of their own examples. And then they are surprised when it underperforms on their actual task. The test set is the 15 minutes that makes the other 50 worth anything. It is the only step that measures the thing you actually care about. So if you take one habit from this whole method, take that one, build the little set of your real examples, and make every model earn its place against them. It is genuinely the difference between choosing on evidence and choosing on vibes. The real lesson under all of it is simple. Test on your own work, not someone else's chart. The model that wins your little test set is the right model for you, full stop, no matter where it ranks publicly. That practical, measure it yourself approach is exactly what this channel is about. Real working systems with honest trade-offs instead of hype and leaderboards. If that is your thing, subscribe and follow along. Subscribe for more AI builds.